Hello, welcome back to algebra class. Today we're going to be talking about GCFs and factoring. Our goal is to be able to find the prime factorization and the greatest common factors of different monomials. A prime number is a whole number greater than 1 for which the only factors are 1 in itself. Some examples include 2, 3, 5, 7, 11, 13, 17, 19, and 23. Once again, there are more, but that's just some of the more basic ones. Composite numbers are numbers that can be made up of multiplying two prime numbers together. 4 can be multiplied by getting 2 times 2. 10 can be gotten by multiplying 2 times 5. So any number that can be a multiple of 2 or more numbers is going to be considered a composite number. So next up we have to talk about what a greatest common factor is. So a greatest common factor is the greatest number that is a factor of both original numbers. So for example, the greatest common factor between 20 and 15 would be 5, because it's the biggest number that can divide both of those two numbers. Two numbers are considered relatively prime if there are no numbers other than 1 that divide both of them. So for example, we could say 15 and 8 are relatively prime because there are there is no number that divides both 15 and 8 that isn't 1. Let's go ahead and do a couple examples here. So I would highly recommend using your graphing calculator to solve these. So we want to find the GCF between 18 and 24. So we're going to press the math button on our graphing calculator. We scroll over to num. I'm sorry, we actually don't scroll over to num. And we want GCD. So once again, I apologize. It is the num category, and we're scrolling down to option number 9, GCD. You press enter. We want to figure out the GCD between 18 and 24. So we have 18, and then we press comma, which is right above the 7. 24. We are going to close our parenthesis, and we'll press enter. Our GCD is 6. That is the greatest common factor. Now we can also have GCFs between things that are also going to be just two monomials with variables in them. So we do the numbers first. So we need to find the GCD between 25 and 49. So I'm going to go ahead and clear that out. Press math, go over to num, scroll all the way down to option number 9, which is GCD. Press enter. So we have 25, comma, 49. Now, their GCF is 1. Also, M and K are not like terms, so the GCF on this problem is 1, and we would say that these two things are relatively prime. So we can find the GCF between three things by simply doing the numbers first again. So we have 72 and 48. So that's going to be our first GCD we do. We say math, over to num, press enter, 72, comma, 48. Our GCD there is 24. So we have to do the GCD between 24 and 6 now. So let's go ahead and do that. Okay, so our GCF there is 6. Now, The thing we need to notice for our variables, if you notice, we have 3x's here, 7x's here, and 4x's here. We want to take the maximum number of x's that all three of them can give. So if we only have 3 here to give, we have 7 here we can give, and we have 4 here to give, we can only give 3 because our smallest one, which is right here, can only give 3. So we can take x to the third. We're going to do the same thing with the y. So we have a y to the fifth, a y to the fourth, and a y to the first. So we have to give evenly, so y to the first is the most that we can give. So our GCF here is 6x to the third y. Let's go ahead and apply this to our factoring work. So to do this, we have to take the GCF of each row. So for example, we have to take the GCF of our top row right here, which the GCF between 3 and 2, there's nothing there. However, they both have an x that they can give. So I write that right on the side there. Here I have the GCF between 9 and 6 is 3. And that is all they actually share. So I have x and 3 there. Now I have to do a little bit of fun puzzle solving here. So I'm asking myself, to get that 3x squared, x times what would give me 3x squared? It's going to be 3x. I do the same thing over here. So I'm going to say x times what would give me 2x? It has to be a 2. So to factor this thing, I can write it in factors. I have x plus 3 is my first factor. That came from this spot right here. And then I have 3x plus 2 is my second factor, which came from right there. So we'll go ahead, try this again here. So we have the GCF between my top row, which I have 3x squared and 2x. So the GCF there, 3 and 2, there is no GCF. So x squared and x, I can pull an x out of that. Do it again, the GCF between 12x and 8. So their GCF is going to be 4. Okay, now I do a little puzzle here. X times what would give me 3x squared? It has to be a 3x. And x times what would give me a 2x? It's got to be a 2. So my final answer is x plus 4, 3x plus 2. Keep moving on. I'm going to do the same exact process. My GCF in my top row is going to be x. GCF in my bottom row is 2. X times what gives me 4x squared? It's got to be 4x. X times what gives me 3x? It is 3. So my final answer is x plus 2 and 4x plus 3. Same thing on the next one. I have 2x squared and a negative 6x, so 2 is going to be the numbers GCF, and I can take an x out of each of those. And then I have 7 and negative 21. The GCF there is 7. So 2x times what gives me 2x squared? Got to be an x. 2x times what gives me a negative 6x? It has to be a negative 3. So my final answer is going to be 2x plus 7 and x minus 3. I'll give you a hint. If you have a negative number touching the border here, you should have a negative answer. So notice I have a negative 6 and I have a negative 3 as part of my answer. Let's look at our next one. So we have 3x squared and 7x. So the GCF there is going to be x. I have a negative 12x and a negative 28. Remember that borders on a negative number, so my GCF is going to have to be negative here. So the GCF between negative 12 and negative 28 winds up being 4, but because it's touching a negative, it's got to be negative 4. X times what gives me 3x squared? It's going to be 3x. And x times what gives me 7x? It's going to be 7. So x minus 4, 3x plus 7. Let's look at our next one. GCF in my top row is going to be 2x. GCF in my bottom row. Remember, it is bordering on a negative, so it's got to be a negative 3. 2x times what gives me 4x squared? It's going to be 2x. 2x times what gives me negative 2x? That's got to be a negative 1. And that is it for today. Good luck on your homework. If you have questions, make sure you sign back on the team chat.